Hi, I'm Gerardo Montano. I'm from the Autonomous University of Nuevo León, and I will give you a quick review about our research and our poster, which is about the detection and removal of alizarin red from aqueous solutions with functionalized carbon nanotubes. The treatment and reuse of textile printing and dyeing wastewater is a major concern in the field of wastewater treatment, and triquinone dyes are the second largest group of synthetic dyes that are widely used to dye textiles. And as an antiquinone dye, alizarin red has been widely used in the textile industry, but it is extremely resistant to typical degradation. This is because due to its structure, which may cause a serious threat to the aquatic ecosystem and human health. Theoretical calculations of single-wall carbon nanotubes and multi-wall carbon nanotubes demonstrate that these can serve as an absorbance with their high active site, large specific surface area, and also exhibit a great performance. In the present work, the optical fiber-based sensor and carbon nanotubes of multilayer functionalities with their functional groups COOH, which are carbon, oxygen, hydrogen, and OH, the effect of contact time, absorbent dose, pH, and temperature on absorption was anticipated. The study evaluated the feasibility of removing alizarin red from aqueous solution using multi-wall carbon nanotubes. Starting with methods, we use a spray paralysis technique for obtaining an array of multi-wall carbon nanotubes on the surface of the tapered optical fiber-based detector. Here we have a little diagram of the spray paralysis process. First, we have the inert gas that goes into a preheater and then into an oven that was at 800 degrees, and at the end we have the exit gases. We had a single mode fiber with a core diameter of 8.2 micrometers and a cladding diameter of 125 micrometers that was used as a base for a tapered optical fiber detector. Here we have a representation of the optical fiber tapered section with these diameters and these lengths. In order to investigate the influence of a red dye concentration on the spectral properties of the tapered optical fiber detector, we made a certain experiment, since the bending angle of a tapered fiber impacts on spectral properties. The tapered optical fiber detector was properly mounted in a liquid chamber. The spectrometer was controlled with a computer by means of the Ocean View software, and inside was filled with carbon nanotubes and alizarin with different pH aqueous solutions. We use pH 4, pH 7, and pH 10. Each one with the same concentration. The tapered optical fiber detector was exposed from 10 minutes to 2 hours straight to every solution, and the respective spectra were recorded. After that, the liquid chamber was washed and dried for 24 hours. Then a spectrum of the tapered optical fiber detector was recorded again in order to evaluate each solution after 24 hours, to evaluate the amount of alizarin that was absorbed by the different types of multiple carbon nanotubes. Here a little representation of the experiment, and down here we have the multi-wall carbon nanotubes and alizarin solutions of pH 4, pH 10 in the middle, and pH 7 after 10 minutes. And on layer B, we have the alizarin and multi-wall carbon nanotube solutions with their respective pH after 21 days. As we can see, the color changes, especially in the pH 10. It means that the alizarin has been absorbed by the multi-wall carbon nanotubes. Here we have a transmission electron microscopy image of multi-wall carbon nanotubes, and on the left side, in BNC, we have the scanning electron microscopy of multi-wall carbon nanotubes after the experiment. We can see that the alizarin is really close to the multi-wall carbon nanotubes, really close on the surface. It means that it's really well absorbed by the multi-wall carbon nanotubes. You have the different absorbance spectra graphics with pH 4, pH 7, and pH 10, being the more percentage of absorbance in pH 10 and in pH 7. At the end, we have the different concentrations of the solutions towards alizarin, and we have weather, washer, and dyeing, and we have different amount of concentration, like 50 for blue, 1000 for green, and 50 for purple. This study shows the great absorption capacity of alizarin that multi-wall carbon nanotubes have in solutions with different pH. As we said, we use pH 4, pH 7, and also pH 10, reaching a percentage of 99.7%, being a promising application for the development of filters that allow us to clean the water of contaminating agents that are used in textile industries. Thank you so much for watching. If you want to look for us, this is our contact.